Welcome back guys on my channel and Happy New Year! Did you like this animation? Well, in this video I'm going to show you how to make it with geometry nodes in Blender. So let's get started. I'm working with the Blender version 4.0.2. We can start making a single curve. Press 7 to see the viewport from the top. The steps for making this animation are these. 1. Create a single vertical line. 2. Create a horizontal line and instantiate it on the first. 3. Having all the lines instantiated, we are going to create a funnel to manipulate the position of these lines to create a funnel. 4. We are going to take all these lines and shift it a little bit to have a width of the funnel, extruding only the last points of the curves. Then we are going to create the line for the output signal, and then we are going to store the information about the colors and the bit signals for all these curves using them in the shading editor. So let's make the first line. We can create a single plane. Shift A, mesh plane, press plus general geometry nodes and new to create the new geometry nodes modifier. Control right drag to drop this connection, 7 to go to the top view, and with F3 we can create a curve line that starts from a negative y to a positive y, okay, because we want to resample it and instantiate another horizontal curve line, okay? So to control this information we can add in the group node a new input, double click, amplitude, that is a float number. We are not going to work in unit measure but in a free values context. So the amplitude will be the amplitude in the y direction of our input lines. From a minimum of 0 we can duplicate this item and set the width as the width of these lines, this space in the negative x-axis. We can set, for example, 1 and 2, 1 for the height and 2 for the width. And for the start and the end point, we can select this amplitude, multiply it by -1, link this in a combine XYZ, linking it in the Y information, link this combine XYZ in the start, duplicate it, link this in the end, link the amplitude to the positive Y, and now for the X we can use the same approach for the width, so we can link the width in a multiply node by -1, and we want to maintain the same value for the X and the X of the start and the end point of the same curve line. Shift, Control and click, and this is the result of this curve. Press H to collapse, enable the snap tool with this button. Now we need another curve line for the horizontal instance. We can leave 0 for the start point and the width itself for the entire length of this curve line. So we need another combine XYZ, link these to the end, leave 0 to the start, and duplicate another time the group input, linking the width in the X, and this is the result here. Now that we have these two curves, we can add an instance on point node, linking the first curve in the points and the second in the curve, but we have only 2 control points in the first curve, so we need to resample it. We can add a resample curve here, and to make a proportional counting, if I increase or decrease the amplitude, we can get the amplitude multiplied by a custom value that you can set here, like 20 for example, and link these to the count. So in this way I can increase or decrease the amplitude and I can get the same amount of proportional lines for the entire length of the first base curve. So now I leave 1 for example, H to collapse. I can link these to the group output of my workflow. And here I need realized instances because I need to play with the curves and not the instances from this output of this node. Now I can select all these nodes, Ctrl J, F2, input lines maker. Next step, I want to offset some of these points along the Y and not the X axis in a random way based by a noise texture. So for this we can add a set position, and this is why I need here a realized instances, because otherwise here I have one object per instance and not the control points of the splines. I need a noise texture, and it's obvious I need a resample curve in between here, because here I have from the first profile curve line only 2 points, the start and the end, and I want to have more points here to be able to offset them on the y-axis. So for this I need a combine XYZ to link it in the offset, and I want to resample by a value multiplied by a proportional number to be able to increase or decrease the entire width of all these lines, maintaining the same proportional counting in this resample curve like before in this point. But this point was about the y-axis. Now we are talking about the x-axis. Okay, press H here, and to do this we can add the group input another time and take not the amplitude but the width and multiply it by a custom number that you can set here, like 7 for example, and link it here. You cannot see any difference because we are not shifting yet the position of the control points. The idea is to use the current position of each of these control points and use these inside this vector of this noise texture. At the same time, we can use the same width as the scale of the noise texture, multiplying it by a custom number. If we want to scale in a proportional way the scale of this noise based by the entire width of the lines as before, so I can link these to the scale and set, for example, 1.5. So in this way, if I increase the width, I also increase the scale of this noise texture. I set 0 and 0 for this detail and roughness. I set 2D because I don't need 3D, the Z component, I don't need it. Remember to check this normalize. So this normalize means that the output of this noise texture will be in a ramp from 0 and 1. If you don't check this normalized, you will get a ramp from -1 and 1. So keep in mind this little difference. Now I check this. Now you can see this thing. I have here a distance between these lines by 0.1 more or less, okay, a bit more between these lines. So I want to offset each of these points, adding here a map range from a range of 0 and 1, so the output of this noise texture, because I normalized it, in a map between a custom value that is less than 0.1 to avoid, if I can say, an overlapping between all these control points while the offset. So if I set 0.08 for example and link these in a multiply by -1, because I need to offset not only in a positive direction of the y but also in a negative direction of the y for all these control points, I need to link these minus here in the start value of the ramp and the positive number to this max. Now I can link these in the y-axis of the combine XYZ to get an offset only in this direction, in a positive or negative direction. You can see we don't have an overlapping of these lines, and if we don't like this pattern, we can add here in between the position and the noise texture an add vector and increase the x to have this wave effect. So if we want to translate along the x-axis the entire pattern, or the y if we want. Now we have ugly offsetting because we have not straight line in the horizontal direction or vertical direction and smooth passage between one value and the shifted value. So if we want to have a more cool effect, we can set here not a linear but a stepped linear range and set only 2 steps. So in this way we can have not a linear shifting of the control points but a step, a jump more or less, okay, by this number of steps in this range of values. So minus 0.08 and plus 0.08. Finally, we can smooth a little bit these control points, adding a fillet curve, setting a poly of 16, for example. We can set 100 millimeters, for example, in this case, and here we have the input lines. We can take all these nodes, press Ctrl J, F2, finalize lines input. Next, we need to create a funnel effect, but keep in mind now here we have few points on these curves, so we can't add a distortion on these lines as they are. So we need another resample curve here with a very high number, always using the group input width, but in a proportional way like before. So if we increase or decrease this width, I want the same proportional resample counting here, okay? Or instead of this technique, you can set here a length if you want. I'm here to show some ways to make this effect, but you can use the method you like. 64, link these to the count, and here we have a very high number of control points here, so now we can add a distortion. And to create a funnel effect, you need to think this. We have a width here that is like a ramp from 0 and 1, and the same for the Y. So we want to create a map range from 0 and 1 and from 0 and 1 to have other input attributes here to manipulate the output of this map range and multiply this output by the amplitude of the input attribute to get a correct Y position and Y offset for each control point of these curves. It's more easy to do it than say it. We can add a set position here after the resample curve, add another group input because we need to use the amplitude and the width. We also need the current position because we need to offset these control points only in the Y direction, okay, near the 0 value of the Y axis, leaving the same Z and X position. So we need to take the position, separated in the three components, get a combine X, Y, Z, link these to the offset, leave the same X and Z. Sorry, not use the offset but the position, because we are starting from the current position and we want to maintain the same X and Z. So the output here is the position and not the offset. We need to get this Y and manipulate this Y to have a new Y information to link here in this combine XYZ. So I need in between a map range, and I need to use the current X value, of all these control points. I link for a moment this Y to have the original position of all these control points. I need to take this X for each one, and I know that this X goes from what value? The width multiplied by -1, okay? The starting point, okay? This point here. And we know always this X goes from these values -1, in this case -2, okay? Here, these values multiplied by -1, and 0 in this case, okay? From here to here, so from max 0, and we want to transform this ramp in a range between not 0 and 1, because after this output we need to multiply this result by what? The original Y component of each control point. So if I link these in a multiply, and I multiply what? The original Y information, like this, and link this Y here, I have this. I don't want this. I want the exact opposite of this. I want to maintain the 0 influence for the first control points, and along the X I want to stretch this point near the 0 value here. So if I set 1 and 0, I can have the opposite value, but I don't want a linear effect. I want a smooth step. Okay, it's better. And not only this, we need here to control this amplitude. So instead of 0, we want to have a range here greater than 0 and less than 1. It's obvious. And for this, we need other two attributes in the group input. One is the funnel amplitude from 0, that is a single value, and another funnel spread from 0. This is the starting value of this range on the x that we want to use to start the stretching of this control point along the funnel. So we can use the width multiplied by this funnel spread. And to manipulate in a correct way this attribute, I need to set a minus of 1 million, for example. And now if I decrease this value, you can see the starting point of the spread of this funnel. And if I set minus 0.5, I have the 50% of the entire width here as the from mean value of this map range. So we have the smooth step from this mean, so this point, 50% of minus 2, so minus 1, and from max 0, okay? And we can insert minus 1 if we want to have the stretching from the start of this width. Now I set the minus 0.3, for example. Now you can see we don't want to have 0 for this stretching, but we want to increase these 2 max as the output. You can see this correct result that we need. So also in this case, we need to manipulate this value with other information like the funnel amplitude. But if we take this funnel amplitude and link this to this max and increase these like 0.1, for example, this result is okay. But if I increase this amplitude, I also have an increasing of this value here. Why? Because in the output of this map range, we have a factor, an influence as a percentage of the original y position of all these control points. So if we have a maximum value here and a minimum value here, I have the proportional output value here, and we don't want this. We want to have a constant output here. And to have this information, you can think if I increase this output, we need a less value of the factor to multiply and to get the same output here for the y, okay? And to do this, we need to take this funnel amplitude and divide this value by the amplitude itself and link this to the ramp. In this way, if I increase the amplitude, I always have the same proportional factor to multiply the original y-axis and the y position of all these control points. If you decrease the amplitude, here we have a greater value here because we want to have a bigger percentage to multiply the original y position and get the same output here. Press H to collapse, H to collapse, H to collapse. H, we can move this set position a little bit, also these nodes. Now we can take all these nodes here, press Ctrl J F2, funnel. Now we need to extend this funnel with the horizontal lines, extruding the last point of all these control points of the curves. And to do this, we need to add a curve to mesh node one time. Why? Because I can't extrude directly these curves as they are in this moment. I need to convert these curves in a mesh, extrude the last point of each curve, and then convert again these meshes in curves. So if I convert these curves in mesh and use the extrude mesh, how can I select only the last point of each curve? I need to capture an attribute before this curve to mesh to be able to select only the last point of each curve, because we have a meshes with vertices connected with edges. And not only these, we need to transform geometry, so to translate the entire geometry here by what? By the funnel width, so a new attribute, a new input attribute. So we can select the funnel amplitude, duplicate this item, move it down, rename it in funnel width from a minimum of 0, it's perfect. Add a transform geometry before the curve to mesh, because we want to move all these objects a little bit. By what? By a combine XYZ node, linking it in a translation socket. Add a group input to take this funnel width, multiplying it by -1 because we want to shift all this geometry on the left on the x-axis. So we need to multiply by -1, link this to the x, and now if I increase this, I can shift this value by, for example, 0.2. Now here, before the curve to mesh, we need a capture attribute, and we need to save the Boolean information about the endpoint selection of the curves, linking this selection here in the value and setting 0 for the start size and 1 for the end size. So in this way we will have 0 for all these control points but the last point of each curve, so 1 1 1 1 and 1 and so on. And now I can take this attribute and link this to the selection after the curve to mesh to extrude only these vertices, not edges or faces, it's obvious. And now if I link this mesh into the geometry, you can see the extruding operation on these vertices, and I can increase or decrease this value. Now the correct direction of this offset is the only vector on the x-axis, so I need to add a combine xyz, leave the y and the z to 0 and set 1 for the x, because this is the direction, the positive direction on the x-axis. Link the vector on the offset, and for the offset scale this value is the exact value of the funnel width, so I can add another group input and link the funnel width, so the same amount of shifting that we used here in the transform geometry but in the opposite direction for this object here. In this way we can end the entire geometry on the 0 value of the x-axis always. So if I increase this value here, you can see the correct result, 0.2. Finally, we need to reconvert this mesh to curves. Select all these nodes, Ctrl J F2, extend the funnel and press H on this combine XYZ because we have a 0 for the other axis that we are not going to use. Next, because we are going to save the information of the bit, so the light, for each control point of these curves, we need to resample another time these curves by very high number. Or if you want to use not very high, at least the same amount of points we set here in the funnel. So we can set a resample curve another time, and because now we have the length of this curve from here to here and the length of the funnel, the width of the funnel, we need to take all this length and resample by a proportional value. You can use, as before, the length approach or the count approach. Now in this example I want to use the count approach. So we need to take the group input, take the width, add the funnel width and multiply by a constant that I don't want to set here, but I want to set in this new attribute here, adding a new input as a bit resolution. This is an integer number, the minimum is 0. I want to multiply this output by this number and link this to the count of this resample curve. Now the bit is too low, so I can set 128, for example. Take these nodes, Ctrl J F2, final resample input lines. Now we finished the input lines signal. We can start to set a color for these input lines to manipulate it in the group input instead of manage it in the shading editor. So for this I can use a store name attribute. We can set a name like variable underscore color and link this value in the group input. Rename this value as input color, and this is not a float but a color, and also in this case this is a color. Link this to this, select all these nodes, Ctrl J F2, color of the inputs, the input lines, and because we are going to use it next, we want to define what curves are the input lines and what curves are the output lines. So for this reason I add a store name attribute another time with a boolean information checked and setting a name as the input. Ctrl J F2, set input lines. Why? Because we are going to add another curve for the output that has a different color and a different information that we are going to use while the animation. In our case, the speed of the animation, the speed of the beats. So for the output line, we need another curve line as the start point of this tutorial. We can add another item here and rename it in output width. We can move it below the funnel. Is a float, single value, minimum 0. We can add the group input another time. Take this output width, link in a combine XYZ in the X socket, link this to the end, press H. Now we need to resample this output line as the input. Now I'm going to use the same approach as this for the final resample input lines. So we needed to take the output width, multiplying it by the bit resolution, and link these where in a resample curve in the count, and link the geometry here. Keep in mind we have not the same bit resolution between these two objects, so these two parts of the object. These will have a different bit resolution than the output line. So if you want the same number of resolution, don't use this approach, but use the length approach and set the same value for both of these two nodes. Now that I have this curve, I can see it if I press Shift, Control and click, but you can't see anything because we don't have a width, so I can set 2, for example, and this is the line. I can duplicate these two nodes here with the Shift D and press Alt P to separate them from this section, G to move, link the geometry inside here, and we need to create a duplicate of this input color for the output color and link these to this variable color. And now we can press Shift, Control and right drag between these two nodes to join them together. Select this viewer, we can drop it with Control X, select all these nodes, Control J F2, output, line and color, press G to move a little bit. Now we have the raw material. Now to create the shading effect and the animation on these curves, we need to save a random value of 1 starting from this first control point of all these curves with a random probability. And next we are going to animate using a simulation zone the shifting of the bit, so the true Boolean value, along the entire curve, and this for all these curves. And this will give us an effect of the animation and the shifting of the light starting from the first point along the entire curve until the end of the curve. So to do this we need two other input attributes, so we can add them. Input bit density, that is the probability to have 1 or 0 along the animation per frame on the first control point of each curve, and a duplication of this input attribute as the output bit density, always from 0, both of them, and the output is for the output curve. If I want to manage in a different way the density and the random values only on this curve, but to distinguish what curves are the inputs and the output, we can use what? A switch and this attribute name, inputs, that are true only for these curves and not for this curve. Okay, so now we want to set a random value only for these first control points, and to do this we need to store name attribute. Here I can set a value of a boolean and a name like bit, the light, the bit, and to have a true or false we can link it in a random value and link this probability using this input bit density. But keep in mind we have inputs and output curves, so we need to add a group input and ask if we have the name attribute of the boolean inputs true or false. So if we have a true value, here we want to have a float number, link this attribute here. And if we have the inputs lines, we want to use the input bit density. Otherwise, we want to use the output bit density, so a different value of the probability, and link this output here. Now, because we want to have a different seed per frame, and because we are going to create an animation, for each frame we want a different value of probability to have a different bit, true or false, in these points here. And to do this, we can use a scene time information and link the frame here in the seed. In this way, we can have a different value of the random per frame. And not only this, because if I press Shift Control and click here and here, you can see anything because we have a zero density and zero density. But if I increase this value like 0.2 and 0.2, for example, you can see all the points are starting to have a light, okay? And because we don't want to start with this pattern, but we want to set only the first point of the curve, so we need to filter this selection using an endpoint selection, setting only the start size to 1 to filter only the first control point for each curve and link these to the section. Now, I cannot use this value in the viewer because we are not filtering the points. So to see the difference, I need to use a sample index node, set here the boolean, add a name attribute as the boolean, link the bit, link this to the value for each index of the control point of the curve, and link these to this viewer, and link the geometry here in the viewer. And you can see only the values set in the first control point of each curve. This is only for the viewing purpose. Now the good thing is that we can take all these nodes here, press Ctrl G to group them together. I can duplicate these and link only the geometry and use these here. I need to rename this information. The true is the input bit density and the false is the output bit density. We can take these two nodes, pressing Shift, Ctrl X. We can cut these two geometry output, delete these two output attributes. And because next we are going to create more than one level of light in these bits, so we are going to create more levels of bits that go along the curves of this object, we can link this name in the group input. I can press Ctrl H on this, drop this, link the name here, Ctrl H, and move these up like this, press tab to exit, and rename this node group in initialize first bit. Now if I take this and link this here, and link this geometry here, and check this eye, you can see the same effect as before. Now this is the starting point for the initial values before using the simulation zone. So now to have an animation of the shifting of these bits, we need to add this in this workflow, a simulation zone, link this geometry inside this simulation, this geometry here in the output, and also in the output of the entire workflow. And here in between, what we need is a duplication of this initialize first bit, because for each frame we need to recalculate a new random value for the first point, control point of all these curves, but also need to move the current value to the next control point of each curve. So for each control point we want to get the previous value of the bit. So to do this, we need to add another time the store name attribute, link this geometry here, and we want to save another time a new value of the same bit information for each control point, but taking the value from a previous index of the control point of the same curve. It's obvious. So for this we need to select only the control points that are not the first, because for the first we already initialized the value, and to do this we need to add an endpoint selection, select only the first, and add here a not boolean operation and link these to this selection. So in this way we ensure that we are going to change the value of the bit only for all the control points but the first. Now to take the correct value we need what? The sample index, because we need to take the boolean information similarly to this approach here, and we want to take the boolean information of the same geometry. It's obvious, from the attribute, the boolean attribute bit, link this attribute here, but we don't want to get the value of the same index of the actual control point we are managing, but we want to subtract from this index an offset of the index, and the offset will give us the same result as the speed of the animation. If I move the light between two control points, okay, each one, I have a speed. If I offset a light with a jump of 2 indexes per frame, I have a double speed, okay, and so on. So we can start with the actual index of the control point, and from this we need to subtract a value based by the speed that we want to use. We can link this to the index and add this value here in the value of the store name attribute. Now to have a more cool effect, we can use a random value between, for example, 0.005 and 3 as the number of index that we want to use as the subtracting operation. And because we have input lines and output lines, we want to have a different speed. We want to have more speed on the output line than the input. And to do this, we can take this, link in a multiply node, multiplying it by 2, 3, 4, whatever. And before going here in the subtract mathematical operation, we need the name attribute with a boolean and selecting only the inputs value. And if we have the inputs line in a switch operator, we need what? Float value. Okay, if we have the inputs line, we want to have this random value. Otherwise, we want to have the increasing of the speed for the output line, and we need to link this value here and then this output in the subtracting component. Now if I press play, you can see the result. We have the animation. You can see for each control point we have a value from the previous control point. Okay, we need to tweak a little bit these values, it's obvious, and we have the same in the output. And now if I increase like 2 for now and I start from this frame, you can see a different speed of animation along this curve. You can see the speed of the transferring information between the control points is not always the same. Why? Because for each control point we have a random value based by its index, and it's wrong because we want to have the same speed for all the control points constant for each curve. So for all this length of this curve we want a single random value for all the control points. For this curve we want another random value, and to have this behavior we need to override this socket, this ID, because Blender in this moment is using the index of all these control point, so a different value for all these control point. And for this we need to use the index in a spline domain, so in a different domain, in this case a spline, and link these in the ID. And in this way we can have a single pattern but different pattern for each spline, and for each spline we will have in this output the same random value, the same speed for all the control points on the same curve. Now if I go in on the first frame and press play, you can see each curve has the own speed, and we have a smooth animation for all the control points of the curves and different speed between the curves. Okay, you can see a different speed for these curves, for example. Okay, from these and this curve we have a different speed. Now another thing, because we have here in an index, Blender when creates these curves start with an index of 0, 1, 2, 3, 4, 5, etc. And at the end of the first curve continues to set a name for the rest of the curves. So if we have 0, 1, 2, 3, 4, 5 and 6, next we have 7, 8, 9, 10, 11, 12, 13, etc. And because we have here an index subtract a value, we have a risk. We could have this index here, this control point, so not the first, okay, but the second, the third, for example, and we could have here a value to subtract that takes the value of the bit not from the first of the same curve, but from the last of the previous curve here, okay? And we don't want to transfer information and bit lights from a curve to the next, and from the next to the other next, and so on. We want to maintain a distance between this information, okay? And to do this, we need to pre-calculate and tweak this subtracting value based by what? Based by the output of this switch. So recap, if I have these indexes here in the first curve and these indexes in the first, we don't want to have 9, this index, minus, for example, a value between 0.005 and 3, like 2, for example, and we don't want to have 9 minus 2, so 8 and 7. We don't want to get the bit light of this index here. We want to stay on the same curve. So if the value of the subtraction is greater than the index of the control point on the curve where it is, we don't want to subtract anything. So you can see for the first curve, the index of each control point is 0, 1, 2, 3, 4, 5, 6, and 7. And the index of these control points on the second curve are 0, 1, 2, 3, 4, 5, 6, and 7 here. So to get these indexes here, we need to add a spline parameter node and use this index. So in this way, if this output of this switch is greater than this index, so in the previous example, if we have 9 here and we have 2 as the output of this random, you can see 2 is greater than 1, so the index of the control point on the same curve where it is. And for this reason, if this is true, so we need to link this in a switch, set this to float. If this is true, we want to subtract how many indexes? 0. Otherwise, the output itself, and link this output of this switch here in the subtract mathematical operation. We can move this a little bit, press H to collapse, and this is how we can create the correct animation between bits. Now we can move these nodes a little bit. We can select all these nodes, Ctrl J, F2, update, current bit value. If we go back to the first frame and press play, you can see the correct animation of all curves. Now let's add some blur effect on this bit, because we don't want to have a single color for each control point, but we want to have a smooth animation between the points. And for this we can start to add at the end of the simulation output a curve to mesh to create the real mesh using a single and simply curve circle. We can leave a 32 resolution and the radius needs to be very low, 0.0025 for example. Link these two nodes, fill caps. We can set the smooth geometry on. Select all these nodes, Ctrl J, F2, curve to mesh. link this to the output. Now we need to create a material for this mesh, and I can set sci-fi lines and set the material inside this our workflow. Okay, I set 2.5 millimeters here in the radius to see the result of the curves and the mesh. For now we can delete the default light, select the plane, and to see the result in the shading editor, we need to go in the shading world, press 7 to see it from the top. Let's add an attribute because we need to take the bit attribute, link this to an emission color, an emission shader, delete the principal BSDF, and link the surface here. And now you can see the same result, but on the mesh. Now the idea is to blur this bit a little bit to create a more cool effect, and to do this we need to go in the geometry nodes, and before the simulation output we need some extra nodes. To blur this bit in another store name attribute, we need a store name attribute node here. We can set here bit blurred, and because we can't blur a boolean value, we need to get the name attribute, the boolean name attribute of the bit for each control point, ask if this is in a switch true or false, and from this get a float value of 0 or 1, and these can be blurred by the blur attribute of Blender. Now we can link the output in the value, set an iteration of 17 for example, so the smoothed range of points near the current control point to have the blur effect, leave the weight to 1, and now because we have a bit value of 1 and we want to add the blurred effect, we need to get the original 1 value of the boolean and add the blur effect to have a peak of white light on the current control point and a stretched and blurred light near itself. Now I can link this to the value, press the button here to see the view per shading preview, press play, and you can see we have the bit and we have the blurred bit. So to see it, we need to go in the shading editor and take another attribute, setting here bit blurred, link this to the color emission, and now you can see the bit with the peak of the white light and the blurred effect of the light near to it. And if I press play, you can see the correct effect on all these curves. Now we can select all these nodes and press Ctrl G to group them together, and because we are going to use these many times outside this group, we can export this name of the bit because we want to create more bit layers, and because we are going to have multiple layers, so multiple peaks of white light on the control points and the blurred effect near to them, we need to sum, to accumulate all the layers together, all the lights of the bit layers together. And to do this, we need to go here, and before linking this add value here in the bit blurred name attribute, we need to take the name attribute, the actual name attribute bit blurred, that is a float number, and add this actual value with the new one of the new layer, because we are going to set a different name for each iteration, for each loop, for each layer, and sum all these influences together. So now I can link these and link these here, and this is the accumulation. We can press Ctrl J, F2, bit accumulation, and now this group is finished. We can press Tab to exit from this group node and rename it in blur bit. Now, because we want more than one layer, we need not a constant name here like bit, but bit plus a suffix, bit 1, bit 2, bit 3, bit 4, etc. And to do this, we need the fantastic repeat zone. We can add these to the simulation zone, link the geometry inside of it, link this geometry here in the initialize first bit, move the repeat zone near the simulation output, link the output of the blur bit here in the repeat output, and link this repeat output to the end of the simulation output. Now that we need more than one bit, we can move this nodes a little bit, select these two nodes here, and take a string, set bit, link this to a join string, because we want to add what? The number of iteration we need to have here. So in the repeat input, we can add a new input. Values is an integer number, iteration. We can link the iteration in a toString field without the decimals and link this to the string. And now we have bit 0, and at the next iteration we have bit 1, bit 2, bit 3, etc. Now we can link this string inside the name of the initialized first bit, so the system will initialize all the layers for the first control point of all these curves. And not only this, we need to link this output of the string, the name of the bit, also here in the store name attribute to save the same name for the bit. So here, and also in this blur bit, because we need a different name. Now if I increase the iteration to 3, for example, and go to the first frame and press play, you can see this particular effect. You can see the correct increasing of the light, but we have some problems. One of these is that we need to change the pattern of the random values that the system gives to all these curves on the first control point of all these curves. And to change the pattern, we can easily link the iteration itself as the seed of the random value here to set a different random value per frame. So I can link this iteration directly here in the seed, like this. We can multiply the speed of the output curve, this curve here, by 4 and not by 2, to have a more cool effect. We forgot to link the bit layer here to get the correct value of the one boolean required for the subtracting mathematical operation to get the correct shifting of the values from the previous control point to the current control point. And to do this, we need to link the bit name correctly here. And you can see we have 3 iterations, but while the animation, we have only one value inside the repeat zone. So, sorry, instead of setting the iteration here, we need to set 0 for the first integer of the value in iteration and set 3, so the number of layers here for the repeat zone. And now we need to take this first value of 0 and add 1 to have the next value and pass this to the output of the repeat zone. In this way, I will have 0 value for the first iteration, 1 to the next, 2 to the next, and so on until this number of iterations. And setting here 3, we will have 3 layers, bit 0, bit 1 and bit 2 with a different speed because we set a different seed, so a different pattern of random values here by the variable of the iteration. Now if I go to the first frame and press play, you can see this effect and you can see these permanent accumulation values. Why? Because we didn't reset the blur effect before the simulation input. So this happens because here in the blur bit we have a bit accumulation, so a continuous increase of this attribute bit blurred all the frames of the animation. So we need to reset this value for all the frames, and to do this we need to add here between the simulation input and the repeat input a new store name attribute, setting the float as the type, the bit blurred variable and the value of 0 before the repeat input to avoid the incorrect blur effect here before the accumulation. Now if I go to the first frame and press play, you can see the correct animation, and you can see frame by frame I have a different layers, and if I zoom a little bit in this zone, for example, you can see this white light going faster than the other. okay, and if I go backwards you can see this effect. Now to make a better effect in the shading editor, we can choose a color for the input, a color for the output curve. We can set for all these attributes a single value because we don't need to use any attribute, any external attribute of the mesh. We can set the output bit density to 0, wait until the touching of the bit to this point, like this, for example, and here from a keyframe of 0 to the next frame we can set a value of 0.3 keyframe. For the input bit density we can set a lower number, as for example 0.08, to not have too much light on these control points. This is the effect. If we want to make the bit more thin, you can easily adjust this bit resolution to 256, for example. Go to the shading editor. We can drop or change the name of this bit to the variable color. It is the color of our curves here. And now because we have the light on this bit with the blur effect and 0 for the values of the other control points, we can multiply this color with a map range of this blurred effect to not have a completely 0 value of the color in these parts, okay, but to maintain a little value of color. So we can link the factor in a map range from 0 to 1 and set for the two min output here, not 0 but 0.1, to have a minimum value of the original color of the curves. Link this result here in the vector because we need to multiply all the three components RGB for this factor here. Link this result as the color of the emission, and you can see the difference in the color. If I increase or decrease these two min, you can set whatever minimum value you like. I stay with 0.1, and for the strength I link this result to a multiply like 36 and link this value to the strength to have more cool effect in our environment. Now you can see a bad result for the effect of the emission. This is why in the engine here, in the bottom part of the color management here, we need to set not a filmic as the view transform, but the new AGX that solves many issues in the color space of the friend filmic. And now you can see a more realistic color of this red value, this red magenta color. We can press play to see the same result in the output of the curve, and you can see the effect is okay. And this was the tutorial. So thank you guys for watching this video. I hope you like it. You can download this entire project on my Gumroad page to get all the animation of the intro with also the entire environment. Please leave a comment, and if you like what I'm doing, please subscribe to my channel, and don't forget to check the bell icon to get the notification of all new posted videos. See you to the next tutorial. Bye!